And we're in another video, which is on question B. And these are just lovely questions. We need to figure out if these things are possible. There's a lovely movie called 12 Angry Men. I urge you to watch it some stage in your life. And one character said, but it is possible. And they're looking at convicting. It's a jury of 12 people that are looking to convict somebody, and they're weighing up the evidence. Great film. It really is. I think it was a stage play to start with. Okay, so back to the mathematics, although they're interlinked. It's possible to have a right-angled scalene triangle. So to do these questions, we need to think, what do each of the descriptions mean? So right-angle triangle, okay, so remember I said most of you are drawing your right angles like that or like that, but push yourself and think, hey, couldn't we draw it like that with the right angle there? So that's the idea of a right-angle triangle. Scalene triangle means what? We said that it had 3 different lengths. That looks more like an isosceles triangle. Let's do one that's going to be like way long, like that. That looks more like a scalene, right? So do you think it's possible to have some sort of triangle that has 3 different lengths, 3 different angles, and has a right angle? Well, let's try and construct it. So let's start with the right angle. Now, does it seem like we could have maybe this side as like a long side, this one as fairly short, and then this one being longer? Which is the biggest angle in this triangle? Well, it must be this 90 degrees. So this must be the longer side. Maybe let's say L, longer side. This one looks like it's a bit shorter. In fact, a right angle triangle, we know this squared plus this squared equals that squared. So it seems like it is possible. Seems like it is possible. It's possible to have a right angle isosceles triangle. Done. Question 8. You saw that it's possible. But from this, again, let's draw our right angle at the bottom here. Here's a right angle. And we're just going to make sure our isosceles triangle, right angle, let's make sure these two are the same length. And those 2 angles are the same. Seems like it's quite possible. Possible to have a right-angled equilateral triangle. Hang on a second. When we did the equilateral triangle, we said that all angles were the same and all 60. None of those are 90. So that doesn't seem quite possible. If we try to draw it, let's have a right angle, and then these side lengths must be the same. So it looks like, hey, maybe those are the same, but then that would be 30. No. So this one seems like it's not possible. It's possible to have an acute angled isosceles triangle. So we're just checking, what does it mean to be an acute angled triangle? There's just a joke looming there about it being cute, isn't there, or something? So, well, acute means it's less than 90 or between 0 and 90. And isosceles means 2 angles are the same. So could we have something where, how should we draw a triangle? Let's do it this way, where all the angles are acute, they're all less than 90, and those 2 angles are the same, and those 2 sides are the same. Definitely looks like it's possible. In fact, that looked like an obtuse one. How about this one? 69. We worked out that this was 69, this was 69, 42. They're all acute. Hey, there was one drawn for us. It's possible to have an obtuse angled isosceles triangle. Well, let's see. Let's maybe put an obtuse angle over here. See, it's bigger than 90 and less than 180. And maybe we can draw that. So we've got 2 sides that are the same. This angle here is bigger than 90 and less than 180. And those 2 are the same. That looks like it's doable. And wait for it. There's one. Look. B was 120. This was 30. Obtuse angled isosceles. So, yeah, we've seen one already. Okay, and that's that for now. Optional questions will be in the next video. I'll see you there.